The first case of dynamic balancing is balancing of single rotating mass. In the case of single rotating mass, I will take the example of the rotor suspended on the end bearings. A very similar example was taken for the static balancing. So what is happening that if there is some unbalanced mass placed on the rotor, then we need a balanced mass to counter the effect of unbalanced force. If there is an unbalanced mass M placed on the rotor and rotor is rotating around the axis of rotation with the angular velocity omega, and this mass M, the unbalanced mass M, has some radial distance from the axis of rotation, which is represented by R. Due to the unbalanced mass, the centrifugal force will act upon the rotating shaft and it will tend to move this shaft in outward direction, therefore causing vibration. To overcome this problem, a balancing mass, or also called as counter mass, has to be placed at some radial distance from the axis of rotation, such that the resultant centrifugal force produced by the counter or balancing mass will totally cancel the effect of force produced by the unbalanced mass. So here is the mathematical representation: the centrifugal force produced by the unbalanced mass, the centrifugal force produced by the balanced mass. Because they are both on the same shaft, therefore the angular rotation will cancel each other. The remaining terms are mass and radial distance, mass and radial distance. So both the forces, if they counter each other, if they equal to each other, then there will be no unbalanced force left on the system, means there is no vibration on the system, and this criteria has to be fulfilled. Mr. has to fill Mr. Mr is equivalent to Mr. Maybe this mass, the unbalanced mass and the balanced mass are of different sizes. If both these masses are different sizes, then definitely the radial distance will be different. So to meet the condition of dynamic balancing in case of rotating objects, we have to counter the centrifugal force produced by the unbalanced force in such a way that we have to use a counter mass or balancing mass at some radial distance from the axis of rotation. So that's all for a single mass on a rotating shaft or rotating object.